Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor. Before we begin, please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It will run for approximately 1 hour with times for questions throughout. I will now turn it over to our speakers for introductions.
Hello, everyone. Nice to meet you. My name is Josh. I am a PM at Microsoft, and I work very closely with Pamela on the Python developer relations team.
Hello, I'm Pamela. I'm on the Python advocacy team, and I like to show Python developers how to build stuff on Azure.
Cool. Welcome to the AI Agents Hackathon live streams. The AI Agents Hack is a free virtual event running from April 8th to 30th.
Yeah, we are going to have a bunch of live streams during this hackathon in order to show you how to build agents using Microsoft technologies. We actually have over 30 sessions. I wasn't able to fit all of them into this slide because we have so many sessions. So our goal is to give you all the knowledge that we have about how to build agents in multiple programming languages: Java, Python, JavaScript, .NET, with multiple Microsoft technologies, from high code even to low code, and to give you all that knowledge so that then you can use it in order to hack on an amazing project and then submit that for prizes. And we even have streams in languages other than English. So we do have a Spanish stream with 8 tracks in it, a Portuguese stream with 3 tracks in it, and a Chinese stream with a few tracks as well. So we hope that we can bring in those of you who are speaking these other languages in addition.
So Pamela mentioned prizes, and we have big ones this time. We do have a bunch of different categories, just like our last hacks. But some things you want to note: each prize amount listed on the right side is per team, and it's not per team member unless you sign up to hack as an individual. So there's a best overall, and then there's a bunch of language-specific categories along with the best Copilot agent category and a best Azure AI agent service usage category. Now, it's really, really important. If you want to be eligible for these prizes, you must register using the link shown on the screen here, aka.ms/agentshack/register. Make sure you go to this page. It should look a little bit like that. And then there's a simple registration form, and you're good to go. And then once you have your submission complete, you have your project all hacked up, just make sure that you and any of your team members, up to 4 people total, you can enter the hack as an individual. You can enter the hack with 2 people, 3 people, up to 4. Just make sure that everybody registers for that hackathon. And then before April 30th at 11:59 p.m. PST, make sure to submit your hack using the process described on that link listed there, aka.ms/agentshack/submit. You're going to need a link to your project repository and a short demo video. And then concluding, following the hack, there will be a couple of weeks where our judges will spend some time scoring your projects, and we'll notify everybody once winners have been announced.
All right. So now we can actually talk a bit about agents. We're going to bring in our colleagues, Marlene and Corey, to go into Agents 101. Thank you.
Hello, everyone. We have the honor to kick off this amazing hackathon full of workshops, 30 of them, but this has to start with one, and Marlene and I are that one. Welcome, Marlene. How are things?
Things are good, Corey. How are things with you? I'm excited to be here for the hackathon with Agents 101. Very excited about that.
Perfect. Well, and hello, everyone. I see everyone in the audience coming globally. Well, first thing we're going to start with is some content that we're just generally going to walk through what you need to know about building AI agents. And even if this is your first time building an AI agent, or you're not familiar with the term, you'll get something out of it, or this is like your 30th time, because we're going to have some advice at the end on, or at least from my perspective of building AI agents, especially for hackathons, and what that entails. A lot of these graphics and the content that we're going to get is actually coming from our AI Agents for Beginners course. If you've taken the course, please write in the chat that you have, so you can make my day. Say that you've seen it, at least the repo. If you haven't, the link is there right below, aka.ms/AI/agents-beginners. That was me. I made that long one for you. But one of the things is how to actually build an agent, or what can you build? So that's what I want to answer for the first time. I love James. James says he's taken this twice, so that's great, James. Right now it's 10 lessons, but we have an 11th lesson, and I want to demo what that is going to look like. So I consider myself a little bit of a hacker myself. Unfortunately, I can't compete in this hackathon. That would be against the rules. But I wanted to build something for you in the lovely audience that could help you with your hackathon project. And one of the things, Marlene, what would you say is like the hardest thing, one of the hardest parts at least, of a hackathon?
I think the hardest parts of the hackathon is coming up with ideas that can actually win, because these are great prizes. I feel like $20,000, I can do a lot with that. In this economy, I can do a lot.
Yes. Yeah,
So
yes.
thinking about
For sure. In this economy, for sure. So I built a little something to help you with that, Marlene, and help everyone else with that. So if you go ahead and put my screen on there, we will demo something to you today. Basically, what I want to do, Marlene, I'm going to say, let's see, I'm going to recommend hackathon projects for the GitHub user. And Marlene, I believe this is your GitHub user name. We're going to confirm this later on. And so this is basically, hopefully you can see this pretty good on your side. It's gonna do a couple of things, but before we go on, let me just confirm. So this is you, Marlene. Give Marlene a follow on GitHub.
exactly.
And this is what we want to do here. And I want to kind of briefly show you some of the processes of an AI agent. And this first step is what you see is a processing request with a GitHub, a hackathon, and an events agent. So the first thing that this GitHub agent does is here are some recommended projects and repositories for the GitHub user. So this is actually going in, it's actually using the GitHub MCP server to get some of your lovely repos that are on your repository now. And it gets a description, maybe some use cases of what that is, so exactly what you've built. And then, it does make some suggestions here, but it's not, we want to win this hackathon, right? We don't want to just, have participating good, but winning is also amazing. So we actually then use this hackathon agent. And what this hackathon agent does is goes in and it has details around this specific hackathon, and also encouraging you to make good ideas around building an AI agent. So let's see here what it suggests to you. So it has this smart document processor is the name, which not very creative on the naming, but okay. So build an AI agent, it intentionally processes various types of document. The agent will use NLP and make it easier to manage their documents. Okay, that's pretty good. I also then see that here it recommends some tools to use, frameworks. And what's really nice about this is it also links to the repos that it uses from your GitHub on exactly where that it's taking place. So, maybe you built some, I don't know if you remember, this is like memory lane for you, but invoice system you at least have in your repo, and some resume analyzer.
Okay, wow.
Yeah. That's some recommendation on architecture, how you might want to implement this as well. And then even, like I said, this is focusing on, getting the prizes. It's going to also recommend some of the prize categories based on that suggestion.
Wow, that's amazing.
So I give you a couple of them to do. So, you have all the options in there. But another thing, a huge thing about this is the learning aspect, right? We have all of these sessions, 30 plus sessions. It might be hard for you to find all of them. And so what this actually does then, I put in a database, in a Azure AI Search database, all of our descriptions of our sessions. And then it should go in and recommend the event name. So this is like some events coming up, the URL, so you can just go ahead and RSVP for that. And I really like doing this with agents. Also, like, tell me why you think this is going to be a good one. And since obviously you use a lot of Python, it's saying, this is going to be great for you to develop agents with Python. We obviously want everyone to attend all the events if that's humanly possible. I don't know, I haven't seen the schedule, but this is one way to kind of weed out and find out what are some of the relevant events for you. So this is actually on the AI agents repo now. This example, it's in a hidden lesson, not necessarily hidden, but it's an MCP lesson that we're currently building. But this code sample you can run, you can use your own GitHub name, and you can get some great suggestions on hackathon projects. So do check that out, and you can run that. And yeah, it's a good start.
Amazing. So cool, Corey. I'm feeling personally inspired by this demo. I hope you were all able to see that, and also will be able to also try it out on your own. I think this is a great way for us to get some ideas. So I think let's jump back into the slides and dive in a little bit more about what agents are.
Let's do it.
So, great. So Corey showed us a great example of an agent that is being able to generate some ideas for us for this hackathon. But what exactly are AI agents? There are a lot of definitions out there on the internet and a lot of disagreements about what an AI agent is. But one definition that we can use is that an agent in LLM-based applications is a semi-autonomous software entity leveraging large language models to perform specific tasks through natural language interaction. So that's one way we can think about agents, is that they're kind of autonomous. They're able to do things on their own, and they're going to leverage LLMs to perform certain tasks through interaction with us. That can seem a little bit abstract and complicated. So another way I like to think about agents or visualize this is through this diagram on the screen here. So we can really think of an agent as an LLM that can perform actions and that has access to different tools and knowledge. And it combines all of these things to be able to achieve a specific goal. So some things that I want to call out about this specifically. One thing to note is that the concept of AI agents is quite an old concept. It existed even before LLMs existed. But when LLMs were created, one of the advantages that we found was that they are able to interact and understand human language and data. And so in that way, they can interact with the environment, get instructions from us, and then perform actions from those instructions or get some understanding of what to do. And a second thing to note is that outside of AI agent systems, LLMs usually don't have a lot of actions they can perform. So if you used ChatGPT in the past, you'll probably know that LLMs really only can perform the action of taking in some user input and responding back with some information or some content. They've improved a little bit now. They're adding different tools to it, but usually they're quite restricted in terms of what they can do or actions they can perform. But now when we introduce tools to these LLMs and give them tools either in their immediate environment, or you're allowing developers to build those tools into those AI agent systems, the LLM is actually able to perform those tasks that we give it. And then third thing that we can focus on here is the knowledge aspect of this, in that LLMs in AI agent systems will have some sort of memory. So that memory can usually be an interaction with the user just in the conversation, which is short-term memory, or they can have long-term memory where they're accessing information from outside of their environment, like with a vector store using some RAG or something to do that. And so when you combine all of these things together, we actually have a really powerful system that you have LLMs being able to take some action. So we're really moving away from just chatting to an LLM like we do with Copilot or ChatGPT, and actually expecting the LLM to take some action on our behalf to achieve a goal. The next thing that we can look at is when to use AI agents. So we have some specific scenarios that we would recommend using agents for. The first is if you have an open-ended problem. So if you have a problem where it's hard to predict what the next task is going to be, it's really going to be difficult in Python, for example, or whatever programming language you're using to use if-else statements at every turn, because you might not know what's the next step that you need to take. And the cool thing with agents, the LLM is going to be able to make decisions and plans so that it can make those decisions for you without having to use an if-else statement. The next thing that we would recommend is to use agents for multi-step processes. So if you have a process that's quite complex and it requires a lot of different tools and tasks to switch between, agents are really great for this because the LLM can really coordinate that switching in between tools. And then a final thing is that agents often improve over time. So when you have these systems, using an AI agent allows the user to give it feedback, maybe from user input or just the environment the LLM is in, and it'll take that feedback and can potentially self-improve. And so you can have these systems that get better over time. So those are the three particular scenarios that we would recommend using agents for. Corey, go ahead. Yeah.
Very nice. Thank you. I feel like I definitely missed a step in my demo, and it should have made a matchmaking agent as well, because everyone in the chat is looking for teams. So that would be my next build option will be a matchmaking for
exactly.
This. Yeah, there you go.
I think about the wrong matchmaking. Yeah, the team part. Exactly.
Team matchmaking, not any other type, please.
Yeah.
I don't want to be liable for anything. So what to your point though, Marlene, what I like about this sample here, just to give you a bit of our architecture of building all these sort of applications, is that there's some limitations to like just a large language model outside the box, but there's obviously some uses, and there's also some uses for making a large language model into an agent, essentially giving it tools and access. And this is a good example of using both those things as well as multiple agents. So in this case, right, we have this customer coming in, and support center or call center, customer support. It's one of the bigger use cases for agents currently. And the first thing that this customer is asking about is something around the smart home thermostat. They have got some problems connecting the Wi-Fi, which is a problem regardless anytime you have one of the new smart home devices, it seems like. And then they keep seeing this error E22, so they have no idea what this is. So they go into a customer support channel or chat or whatever. And out of the start of this process is a query processing using just a regular large language model, not an agent per se. And it's just basically getting out the details of that message, which is the top, like the device or subject area, Wi-Fi, the error that it has, and exactly the device. This goes to a planning agent that actually knows in terms of the available agents to resolve this issue. And in this case, we have 3 different agents. One is a video agent that can look at video clips that maybe it's in our knowledge database, or we've stored somewhere the transcripts, and could find exactly where in that video we resolve E22 as an error. Then we also have some maybe internal tips and things like that we also want to include into this answer. And then let's say we're just the company selling these thermostats. We don't know the ones that are making it. Then we have going out to maybe the manufacturer of the thermostat to get that information as well. So all these agents are collaborating again with each other, and then basically presenting their findings or results, if you will, and having the planner agent say, okay, with all this responses, does this answer the question, right? We won't get into specifics of different frameworks and how they work, but within most of these frameworks, we have this ability to define where the conversation terminates or when the end result is, and then we can present an amazing answer to the user or to the customer in that regard. So when you think about architecting your hackathon projects, look at it from this angle. I think it definitely is a good one.
Great explanation, Corey. I I think another thing we are going to talk about as well is how can you actually get started building your AI agents. So for example, we here at Microsoft offer many different tools for you to get started depending on your level of technical skills. So for any users any of you that are here that are watching and you are not as technical, there is an option for you. So that would be Agent Builder. And this really allows you to have a no-code option for making custom copilots or custom agents. And then for users that are a bit more technical, but maybe you're not a software engineer, but you can write a little bit of code, Copilot Studio is a great way to build copilots with a minimal amount of code, but it allows you more flexibility compared to Agent Builder. And then finally, for developers, we have Copilot Studio that integrates with Visual Studio Code and allows you to customize your copilots. And we also have a large range of developer tools that we are going to talk about to be able to build things out as well. And when I'm talking about developer tools, specifically, if you are someone that's comfortable with writing code, which I think a lot of us hopefully will be comfortable with one language or another, the first thing that we're going to recommend is if you are just building a single agent. So if you're working with deploying one agent, we would recommend using Azure AI Agent Service. And this is for a scenario where you are going to create it creates a microservice for you to be able to launch and deploy your agent. And it'll give your agent access, your LLM access to all of the tools that we talked about earlier. And it also comes with thread storage, so you can have memory of your conversation, both long and short-term memory. So that would be if you're building out a single agent. And then if you want to build out something a little bit more complex that requires multiple different agents, we will have some hackathon lessons on that. Then we would recommend two options for that for making orchestration between your agents easier. The first option would be AutoGen that comes from Microsoft Research. AutoGen is amazing. It includes some state-of-the-art orchestration strategies and just the state-of-the-art, the newest and latest technology. But because it's coming from Microsoft Research, there's often some breaking changes and it's a little bit experimental. If you are looking for something a little bit more production ready and more stable, we would then as well recommend Semantic Kernel, which is also an orchestration AI agent framework, but it's designed more for production scenarios. So those are the main agent tools that we would recommend for you to use during the hackathon this next couple of days.
Okay, so now we're going to talk about how to make good AI agents. And I realize now it might seem that what we just said might be didn't apply to making good AI agents, but we didn't tell you how to make bad AI agents. What this means is just how to apply different design principles in terms of agentic design. So I guess there's three areas that you want to sort of focus on when you're talking about building an AI agent. One is space, and this is just basically meaning that the agent that you're designing operates in an environment. And what we mean by an environment basically could mean whatever systems it's using, whether it's making tool calls. Like for example, the environment for this hackathon agent that I made could be the GitHub MCP server in terms of its tools, right? As well, and I need to be cognizant, or at least recognizing that this is an environment that might change. Like I'm hoping Marlene will continue to make repos in her GitHub. I'm pretty sure she will, right? So if I just did that one time, call to get her repos and said that was it, that wouldn't be a good agentic design, right? So I need to make sure that maybe I'm making more calls to this so that I can get updates, and then update how she's developing so that we can get more relevant hackathon examples, maybe for next year's hackathon. I don't know. Well, maybe we'll do this next year. I don't know. But and then on time side, right, is that these interactions between user and agent can happen within context, but it can be also over time as well. Marlene already explained some things around improvements of agents in this long-term memory. And you as the developer or the curator of the AI agent need to sort of manage that relationship of like when a user comes back, do I want, for example, to have the same exact suggestions when Marlene asks about recommending hackathon projects tomorrow as she did today, or should I do new ones? And maybe for this application I want to do new ones, right? I want to make sure, so I will store those recommendations in a database and then make sure that the agent doesn't make the same ones over again, because that would get kind of boring. And then at the core of this, so that's the last principle, is that we are still working with large language models. And, to the point of, and this is almost accidental, but I'm going to go ahead and give myself credit for it, is that once, I typed in, recommend the hackathon project for that GitHub user, for Marlene's GitHub name, it said, oh, okay, great. I'm calling the GitHub agent, I'm calling the hackathon agent, and I'm calling the events agent. So knowing and being clear to the user that they are interacting with an agent is one of the core things, because sometimes, in this case, like, it talked about products that maybe aren't relevant anymore or aren't the names, because we change names at Microsoft sometimes, right? So, also being clear with that and the limitations of your AI agent is core to working and designing good AI agent experiences.
Amazing. So some other things that we are going to look at now are some design patterns or common ways of designing agentic flows to incorporate tools, knowledge, and access and actions with your AI agents. So the first thing we're going to talk about is tool integration in conversational agents. So if you are working with an LLM that you are going to be using chat completions for example, how do you actually give that agent tools? And so you might start from this place here, like we can see on the screen. So maybe you have a sales agent that you want to build out. So you'll start by choosing a model. So maybe I want to choose GPT-4o to build out the sales agent as my LLM. And I'm going to give that LLM a base prompt. So I'm going to say you are an advanced sales analysis agent and you're specializing in assisting users with sales inquiries. So I'm giving that LLM sort of this base to know this is the agent you are operating as. And then after that, I can give it access to data. So whether that is going to be with Azure AI Search as a vector store, or files on my machine, or files in Azure Blob Storage, for example, you can give it access to some data that it will be able to use for getting relevant context. You can also give it direct access to tools. So what do we mean when we talk about tools? We mean anything that will allow the LLM to perform an action. And that action could be something like calling a file search on Azure AI Search, or that could be something like running a code interpreter to run some code, or it could be searching the internet with Bing search. So these tools are things that we want to be able to give our LLM access to. And one way to be able to do that, so say, for example, our user sends in a message and asking, tell me the total sales by region. We know that the LLM has access to, maybe we've given the LLM access to some Python code that can access an SQL database. What the agent is going to do is it's going to use something called function calling. And we have a whole lesson in the Beginner AI for Beginners course that you can take a look at that goes into how function calling works. But what basically happens is that the LLM will then read the description of the tools that are available. So it'll know that there's a query SQL-like database tool, and it'll know that the user is asking for some sales data, and I can probably get that from this tool. And it will select that tool, call that tool with a function call, and then it will return a response to the user with the answer once it's done that. So what happens then when the user asks a different question? So for example, the user is saying, show a pie chart, this information as a pie chart. So obviously in this case, the LLM can't use the query database function that it's used, or that query database tool. So in this case, it will probably need to call the code interpreter so that it can take that sales information and turn it into a pie chart. And so again, what the agent is going to do, it's going to look through the different functions or tools that it has available to it. It's going to see which tool is correct, corresponding to the user input, choose that tool, run that tool, and then send the message back as a response to the user. So this is basically how your LLM is going to act and interact with tools through something called function calling. So that's the first thing when we're talking about tool integration with conversational agents. The second thing we also want to talk about is tool integration in agentic RAG. So RAG is retrieval augmented generation. And this is a way of getting an LLM to answer a question about your own data. So the LLM will first go ahead and retrieve relevant context from your data, and that data will be sent to the LLM so that it knows how to answer based off of that data. So there are many ways that we can use agentic patterns to improve RAG and increase the accuracy of our answers from the LLM. One way to do that is what we can see on the screen, where a user would input a question, and then the LLM would analyze that question, and it would do several things. So it might go ahead and decide which tools to call, whether that's an API tool or look through different documents or a database, and just look for information anywhere it can find that. And then it's going to collect all of that information into a group of results. And then it will pass that information, those results, either to a model or to an algorithm that will decide whether the quality of those results are good enough and whether it's good enough to send to the user or not. And if it's not good enough, it's going to repeat the process of analyzing the user's query, getting the information again, and updating the results. If it is good enough, then it will generate a response using that information and give it to the user, and also finally update the memory of this conversation for future reference. So that is pretty much as well how we would use agentic RAG. Now, a final thing I want to talk about in terms of tool use is something called MCP, which is quite new. It's called Model Context Protocol. And this is an open protocol that standardizes how applications provide context to LLMs. So we can think about MCPs at their website. Actually, they give this illustration, and they say you can think about MCP like a USB-C port for AI applications. So just like USB-C provides a standardized way to connect your devices to various accessories or tools, MCP provides a standardized way to connect AI models to different data sources and tools. So Corey gave an example earlier where he was able to use an LLM to communicate with my GitHub repo. And the way he was doing that was through the standard protocol called MCP. So this is very new. So if you want to build an agent on this, you're probably going to be experimenting with lots of new things, but it's really powerful if you're able to get it right. So those are the main things we're going to talk about in terms of tool use. So Corey, can you tell us a little bit more about building trustworthy AI agents?
I can, but I would say, I'm going to take back my words that maybe it's just me, but I said that, finding hackathon ideas is hard, but I came up with another one from the chat. I saw that there's a recommendation of making a Fox bot. Pamela, so we're getting a lot of questions around, can I do this hackathon solo? Which the answer is yes. Do I need to use Azure AI services, or can I use something else? Which also is the answer is yes. But if you are using without, you need to be very clear in your README. So that's just to give some to people in the chat who maybe are not tracking everything, but I could totally make a bot for this. And maybe I will. No one's gonna stop me because we have a Discord server, which I'm a moderator on, so I could definitely at least deploy it there.
Yeah, 100%.
Yeah, given some time. I mean, I'm seeing all the questions. This could be good, everyone. But absolutely. Yeah, this is like a third agent idea that we already had in this chat. Wow, it's amazing. Agents, what a time to be building. But don't just build trustworthy AI agents, and that's what I'm going to talk about now. And there's a few different tools or techniques, I would say, to really implement what generally this idea of trustworthiness. And that's one, we want to make sure the agent is doing what we intended to do or what we designed as agent designers and builders, and also making sure that we can make this in a very repeatable or scalable way. Because again, if we find a good way to make an agent and you are making multiple of them, you definitely want to just keep using that method. So this first slide is kind of messaging this idea of system message framework. In a system message or instructions or system prompts, whatever you would like to call it, whatever you're familiar with in that terminology. I know there's a few out there. We at Microsoft refer to this very clearly as system message, is a way that you're kind of giving the meta instructions to an LLM in general. So if you build any type of generative AI application or LLMs, you've probably done this before, or like a chat completion type of interaction. But in the case of agents, it's even more, I say at least even more important, right? Because obviously the agents are taking action. So if they don't take that action or take the wrong action, it's not as fun. Like, yeah, maybe an agent doesn't have the right answer in terms of maybe retrieving something. Like, okay, but if you're doing the wrong thing, as an agent builder, it's frustrating. Like, oh no, I told you the tool's right here. Why are you not doing it, right? So this idea of system message framework is basically allowing you to design one kind of template system message for generating system messages. And in the course, again, AI Agents for Beginners, we have that code sample of this. So I think it'd make it a bit more real to you. But basically, like you could say, here's a system message. You're really good at generating AI agents system messages, and they should have these sorts of things. And you then, as a designer, can come in and say, you are a GitHub agent, and you're just here to recommend hackathon projects. And this, if you run it through this sort of framework, you actually get a very much more robust and very clear prompt that you can give to that GitHub agent rather than me trying to write it by hand. And why it's a framework rather than, you just use LLMs to generate the prompt, is that you can then now scale this over to multiple agents. So if you have a good structure and framework, because a lot of times the goal of most of the agents are the same in terms of like the ultimate user goal, but the subtasks are different. So in the example we have in the course, AI Agents for Beginners, it's basically doing travel. And, each of these agents is something like booking flights or booking hotels, something like that. And you use this framework to define all of those things first. And I can just say, you're an agent booking flights. And I get this beautiful prompt for the booking flight agent. So it's just a way to kind of keep this scalable and repeatable, which is one of the tenets of trustworthy. But there's a few other things. So if we go to the next slide. Another thing that we get a lot of questions on is human in the loop. Basically, this idea of, maybe I don't want just the agents. I know we kind of define agents as semi-autonomous, right? Because the agents are still using, in terms of when they're making some of these actions, a user is interacting with them. They're not just like, I'm going to go ahead and book a flight now because I'm just feeling like Hawaii, right? They have the user has to like ask about those things, right? So there's also this element that then you also want to make sure, like, let's say you are booking a flight or you're making some sort of action, that you want the user involved to, push the confirm button, or you confirm that this is the right details before you perform that action. It's very important for certain use cases, maybe not for all of them, like, getting your GitHub repo. I don't need you in your express permission to to do that, right? But there's this idea of basically representing a user as a human. This can be done both with the Microsoft frameworks out there. I know AutoGen has this kind of proxy user agent terminology, but this also can be done and replicated in semantic kernel. But essentially, like I said, when you're doing this, managing these multiple conversations between agents, you can define when that conversation terminates or when it continues. And you basically are prompting the user acting as an agent, essentially in this group chat, collaborative chat, to say, oh yeah, confirm, buy, shop, whatever. And then the agent then performs action. So basically the agent is waiting for a response or a prompt, and in a very defined way that you design as an AI agent designer to do that. And then it reaches the user goal, or it says, reject. I don't want to do that. I don't want to go to Hawaii anymore. Never mind. Or this, I don't like the, window seat. I don't know, whatever. But these are all things that you can kind of think about when you're designing, because I know a lot of people, when they go and think about the use cases or the hackathons, they immediately get into these scenarios of, the AI agent probably should ask somebody before doing it. And this is the human in the loop kind of architecture design pattern is where you kind of do with that. And then the other one, even most important, I think, we're doing this for hackathons, and hopefully, a hackathon would be beautiful that like you build a hackathon and then it becomes a real product. You apply for Microsoft for startups, you get funding, and then you come back to us, Marlena, you find us on LinkedIn or blue sky or whatever, you say, I built this beautiful startup just because I attended your 1 hour session on Agents 101. Maybe that's the dream, but maybe you're just going to make a hackathon project just to, get your feet wet on designing AI agents, and that might be it. But even if that's the case, evaluating your AI agent will make your life much better, I think, in designing these AI agents during the hackathon or with outside of the hackathon. And really, when we're talking about evaluations as well, is that this is you're evaluating every sort of interaction between the user, the agent, and basically everything else. So the user, we're making sure you recognize the intent of the user, because again, that's when we talk about tool calling, especially. To pick the right tool, you need to know what kind of intent or what goal the user is having, so you can kind of evaluate on that. The actual cost of the tools themselves. So, again, I use the GitHub MCP server, and then also my Azure AI Search Index, and also evaluating the responses of those response times, making sure you actually get those correctly is a super important thing, right? Because in cases of when the responses don't come back, how does your agent respond, right? Maybe, again, you might lose your co-host like I just did. Like, how am I going to respond? Do I just stop doing anything? No, I'm going to keep going presenting, even though Marlene is gone. I don't know what happened to her. Hopefully she's back, right? So you want to make sure when you're evaluating these things, the agent has that built in, and you can kind of monitor and observe all of those things. I could see Marlene's screen, so hopefully she can change it. Yeah, perfect. So my advice on building AI agents, and this is going to be my personal advice, again, building a lot of agents and also doing quite a few hackathons around the space as well. First off, it's very fun. I know these kids can look a little scary, but rest assured, they are having fun building AI agents. But to be honest, I don't want to be like the Debbie Downer person or ruin the vibe. But it can actually be really difficult at times, especially when we start adding multiple agents and more complexity around tools. So I really like this quote. I think I got it from maybe a podcast or something like that. But it's very interesting because it says, if you think we're close to AGI, try building an AI agent. And it just shows, again, because there'll be moments while you're building these agents and you think it's very clear to you, you design it, but there's a lot of intricacies about designing these instructions, making sure these instructions are repeatable, and then making sure the agent is very clear that it's only going to make this tool call or use this database for that. So I have a few tips, 5 tips to kind of get you through that. All again based on experience from these hands are vibe coding through AI agents. First one is like list the tools and knowledge that you're going to need. It's very important. Again, because you're going to have an idea, and you might just say, okay, I don't know where to find those things, or like I have an idea to do the GitHub thing, right? Obviously, GitHub is going to be where I get the repos, but what about the descriptions of the event, right? Okay, we have the Reactor website. So listing these out and kind of architecting, which is my another tip, is like diagramming the agent flow. I know there's actually some tools out there to do that and actually generate some code and stuff like that. But knowing the flow, like, okay, the GitHub agent gets the repos. The repos are then given to the Hackathon agent, which has this data and it's going to make the creative suggestions. And then based on those suggestions, it gets to the events agent, who's going to look at the Azure Search database and pull in the relevant things. So just architecting that kind of stuff is really important. I know a lot of people do that naturally. I don't do that, but specifically for agents, it's very good practice. Developing each agent and tool iteratively, I can't even say it, largely because I think, you get this grand idea about, we're going to have these 3 agents do all these things, but it's very great to get one agent working on one thing first, making the call to GitHub. Okay, great. Okay, now I'm going to get this Hackathon agent to be able to suggest great Hackathon projects. Okay, great. I'm going to get this RAG plugin agent that I made to get the RAG data, and then kind of tying those together instead of thinking you're going to get all of these done immediately in one step. Because also from a hackathon perspective, if let's say you don't finish in the hackathon time, you'll still have 2 working agents, right? And that could still apply to whatever you're trying to do rather than the 3rd one because you didn't have enough time. The fourth thing is hard code if needed. I know that's kind of crazy to say, but even in the demo, and this is secrets revealed, you can look at the code in the AI agents for beginners. Right now, it actually hard codes looking at if you mention anything about hackathons or suggestions, it's then going to start this agent workflow. I should, and that's what I'm kind of getting to the next, is getting a large language model to route that information once it's in the contents. So it's not hard coded, and it gives a bit more flair to and more flexibility to the application itself. So that's another thing. Especially when you want to test things out and make sure that the flow works at least, hard coding is definitely a good option first, and then you can remove that, use a large language model to be more flexible in those sorts of things. And the last one, which I think is the killer for hackathon projects, is don't overcommit to one tool or pattern. We talked about a few design patterns now, but one of the things is you might get stuck on for this GitHub thing, I definitely had to use GitHub, but maybe let's say the MCP server wasn't able to give me the repos that I wanted, or that wasn't able to analyze the repos for whatever reason. Maybe I could use another tool, or maybe use directly the API or whatever, instead of me kind of being caught up on I need to show MCP to this lovely audience because MCP is so great and everybody needs to know about it. I could have just said, okay, we're not going to use MCP because it wasn't sufficient here. And I think that happens a lot of times when you're hacking, is that you get caught up, you want to use this one tool because you see all the options it has, but maybe just not necessarily getting to that one piece of data or response or things like that. So don't overcommit to it. Look around. Don't fall into the quicksand again of kind of like falling into looking at that one tool. So that's my 5 tips. Then the one big tip, if this is all completely new to you and you want to get some applied knowledge, this AI agents for beginners, again, we have 10 lessons and an 11th lesson coming soon, or actually 12 lessons, but the MCP sample, the code sample I showed you is actually going to be is actually already in the repo under the code samples for MCP. So do check that out. And this is a great way to get kind of looking at the code samples, playing around it, breaking it, and you'll get your hands on knowledge of building these AI agents, at least in Python.
Amazing. Yep, just a reminder to check out the course. And I think that's all we have for now. I thank you, Corey. Thanks everyone for joining us. I believe Pamela is going to join us.
Pamela's going to join us and talk, I think, about some AI agents with Microsoft services specifically.
Exactly.
All right. Thank you so much, Corey and Marlene. That was awesome. As a reminder, definitely dig into that AI Agents for Beginner curriculum if you want to get more into everything that they were talking about. And in that repo, there's also all these code examples too. We're not showing a lot of code. We're not showing any code today, actually, because, we've got Python developers and JavaScript and Java and C#, like all of you coming in with different languages. And, we want to be inclusive. So we're going to be talking today more about what can be done and not how to do it. You'll learn how to do that in the streams that come up for your favorite language. So now I'm going to talk about more into how we can build an agent using Microsoft technologies, and also talk about all the upcoming streams that we have that will teach you how to do this. So when we're building an agent, what do we need? At the minimum, we need an LLM, right? Because we said that an agent is using an LLM in order to improve our workflows, right? So we need the LLM. The LLM is going to make decisions and generate responses. Now, our options for Microsoft is Azure OpenAI, and that's what a lot of our samples use. That's where we get really powerful models. There's also the Azure AI Model Catalog, which has models besides OpenAI models. So it's got Llama, Mistral, Cohere, Jamba, DeepSeek. It's got a lot of really cool models. There's GitHub models, and GitHub models has basically the most popular ones from that model catalog. So once again, we've got Mistral, Cohere, Llama. And the really cool thing about GitHub models is that you can start using them for free. All you need is a GitHub account. Let me actually show GitHub models because I really want to plug it, because this is the way that you can start developing for free, right? So you can use any of these models here, including OpenAI, so OpenAI, Phi, Cohere, DeepSeek, Llama, Mistral, etc. You can, get started with these models. You probably want to start with the, GPT-4o or GPT-4o mini. and then you can start using them. And one of the things I shared in the chat is that I have a repo that is specifically shows you how to use GitHub models with popular AI agent frameworks, right? So we've got AutoGen, LangGraph, Llama Index, the OpenAI Agents SDK, the OpenAI Normal SDK, Pydantic AI, Semantic Kernel, Smol Agents. So a ton of different AI frameworks. They can all use GitHub models, and GitHub models are free as long as you have a GitHub account. They are rate limited, so you may run out of quota on some days. I still haven't actually run through my quota, which is great. But they're free, they're rate limited, and it's a great way of getting started and building your agent. And so you could build your entire agent using GitHub models for free, and that way you don't have to use any Azure credits, and you don't have to sign up for anything. So that is definitely an option that I want everyone to know about. You could also use models locally. So for example, you can run Ollama. I've got Ollama running. There's my little llama up there in the corner. And there I've got like the Phi model downloaded, right? So you could be, running with local models too. The important thing about the LLM is that we generally need it to support function calling. That's a specific capability of an LLM. Not all of the LLMs support it. The GPT 4.0, 4.0 mini, those definitely support it. Llama 3.1, 3.0, those support it. But not all of them support it. So generally what you're looking for is a powerful LLM that supports function calling. And if you have that, then awesome, you can build an agent. The next thing that you often want is an orchestrator that's going to manage calls to the LLMs, right? And you want one that has this kind of agent-oriented orchestrator. So it knows how to call tools. Usually it has some way of storing memory, some way of showing you steps along the way, some way of doing planning in order to plan, which agents it's going to call, which tools it's going to call. So from Microsoft, we have Semantic Kernel, which is available in Python and C#, and then we have AutoGen, which is available in Python. And then we also have various Azure AI SDKs. So those are offerings from Microsoft, which you could use, but you're also welcome to use open source packages because they're pretty much all compatible with Azure and compatible with GitHub models. You just have to point them at the right model, right? So you might use LangChain or Llama Index or Crew AI or, any of the ones I just showed in that repo. All right, now, but you don't have to use the orchestrator. Some people actually just go really low level and, create an AI agent from scratch. But I do think it really helps to start with an orchestrator to get a lot of the functionality for free. My personal favorite is AutoGen. So far, I found that the most intuitive, but everybody has their own framework. I should actually change this to say LangGraph instead of LangChain. If you are specifically building agents, most people actually do it with LangGraph, but you can also use LangChain. So they've got two offerings there. Okay, so now you're orchestrating calls LLMs. And, usually your LLMs are either going to be retrieving knowledge from data stores or putting knowledge back into data stores, or, both, right? So where are you going to get that knowledge from? Where are you going to store it? So if you're doing search and you need to search a bunch of documents, then you probably want to use Azure AI Search. Or maybe you're setting up a SQL database. We've got Azure SQL, Cosmos DB, Postgres, right? If you're just storing files, maybe you'd use Azure Blob Storage, right? So we have lots of different options for data stores. If you are doing everything locally, then, there's ways of doing all this locally too and doing it in memory. So you've got options there too. There's also emulators for everything, right? You can run Postgres locally. You can run a Cosmos emulator locally. So you've got local options too, because once again, local meaning low cost, right? And we want to give you all these low cost options because when you're learning things, you don't want to spend a lot of money. You ideally don't want to spend any money. So we want to make sure that you know about all the low cost options available. Finally, tools. One of the main things that makes agents powerful is that we empower them with tools. We're like, oh, hey, agent, you need to do math? Here's a calculator. You need to browse the web? Here's a web browser, right? You need to extract information from a PDF? here is a tool that can do that, right? So we do have a bunch of services for that. There's Azure Document Intelligence. That one's really good for extracting information from documents. We've got the Azure Speech APIs, really good input-output, really fluid voices. We've got Bing Search Grounding. We've got communication services if you want to do like a WhatsApp integration. So lots of different tools there. And a lot of these do have a free tier. So if you want to experiment with these for free, just look to see if they have a free tier and see what the limitations of the free tier are. Because once again, we want you to be able to learn without having to spend money. So for all of these options, we are going to have streams that show you how to use them from experts within Microsoft and our MVP community. So with the LLM options, lots and lots of the streams will be talking about Azure OpenAI. I've highlighted a few of them that are specifically talking about the voice model, the real-time preview model, right? So if you're interested specifically in the voice model, we've got sessions, but really so many of the sessions will be using Azure OpenAI because they're very powerful models and it's what we tend to use by default. So you're going to learn about Azure OpenAI in lots of sessions. Now for the Azure AI model catalog, we have a talk from Facundo on that team, and it'll be in both English and Spanish about building an agent with an army of models. And there he's really going to talk about like, how do you decide which model to pick for what, right? So do you use Phi for this step and then Llama for this step? And, you know, once again, all these models are also available on GitHub Models. So the things he talks about there, we can use that with GitHub Models. And then for GitHub Models specifically, I am going to do a talk about that on April 15th, where I'm going to go through all the demos in that repo and, you know, just talk through them. So do come to that talk on April 15th if you're really interested in GitHub Models as your way of getting started. Now, at Azure, we do have the Azure AI Agent Service. Now, what this basically is, it's like a managed agent microservice that has built-in tools and built-in memory. And that's like the reason for why you might want to use it is if you want those built-in tools and that built-in memory, those would be the reasons to use it. And many people do want their agents to have access to certain tools and especially to have easy ability to remember threads and store memory across sessions. So we're going to have multiple sessions about that, starting with one from Marlene, who you just met, but we'll have ones about using the AI agent service with Python, with .NET, with JavaScript, and also with Azure Functions. And we do have a specific prize for the Azure AI agent service to motivate you to try it out. Once again, this one does require you to have an Azure account and to sign up and to use some credits. But we do encourage you to check it out, at least go to the sessions, learn what it's about, learn when you might want to use Azure AI agent service versus just an LLM with a framework, right? That's kind of a decision that you need to make. And you can also use in combination. So you can actually use like semantic kernel with the AI agent service if you want to combine them that way. Orchestrators. We do have multiple orchestrators, right? So we have semantic kernel. We're going to have talks about how to use semantic kernel in Python, how to use it in Java, how to combine it with different, different tools like Azure Cosmos DB. We also have a talk from the AutoGen team about how to build apps with AutoGen in Python. So that should be really cool. We also have talked about open source orchestrators. So we have Lori coming from Llama Index. Lori works for Llama Index and is their head of DevRel. So Lori, he'll be telling us how to use Llama Index in TypeScript in order to augment your RAG. And we also have multiple talks that are going to be using LangChain and LangGraph. So you're definitely encouraged to use open source orchestrators if you like the way that they go about things, right? All these orchestrators have slightly different ways of doing things. So I think it's really helpful to see multiple options and see what really works for you and say like, yes, I like that one. I like the way it's doing, like that works for my brain and I'm going to use that one. For data stores, we're going to have talks from the Cosmos DB team. We're going to have multiple talks from the AI search team about how to do agentic RAG and how to do voice RAG. So that should be really cool for those of you who are interested in RAG from the chat. We also have talks from our SQL team. So we have Davide from Azure SQL, and he always does great talks. And we've got two about Postgres, one in Python, one in C#. All right. Now, when you're making your agent, you have to decide where it's, what kind of agent is it? Is it going to be an agent that actually lives inside another tool, right? So you can actually make agents to extend the Microsoft 365 Copilot. That's a very popular use of agents, is to make those tools more powerful. Or you could be doing standalone agents that you're, just using for your own purposes that aren't necessarily living inside. They're not embedded inside an existing Copilot, right? So that's two different ways of thinking about where your agent live. What is its environment? So for Copilot, we're going to have a bunch of talks about building for Copilot, if that's what you're interested in. And there is a prize specifically for that. So if you're into Copilot, go for it and go for that prize. And then we also have talked specifically about different Azure clouds. Azure Functions is a really good fit for agents, really, really good. Also really good for MCP. We just came out with this Azure Functions MCP repo, actually a bunch of repos in each language. So if you're interested in MCP, an authenticated MCP server, you should check out Azure Functions. And we have a few talks about Azure Container Apps, which are really good if you're doing code interpreters. Okay, now over to Josh for next steps.
Hi, everyone. Hope you enjoyed today's session. If you aren't already registered for the AI Agents Hackathon yet, you can register now at the aka.ms/agentshack. Danny, do you mind moving to the next slide?
Oh, that's me. I'm Danny.
Okay. Pamela. Yeah, so there's the link that I just was just listing. If you have any questions along the way, I know there's been a ton of discussion in our comments just now, and we weren't able to answer everything. Frankly, we need a Fox spot, right? You can go to our GitHub forum, linked aka.ms/agentshack/ resources, and you can go there and take a look at our resources. You can ask questions there, and there's also a ton of other things that you can see there. There's also the aka.ms/agentshack/discord, which brings you to our Discord office hours, and you can take a look at that if you're wanting to ask some of our speakers questions live. I also encourage you all to attend more of our live expert sessions, and you can find those at aka.ms/agentshack/streams. There's a ton of different tracks that you can look into, whether you're a Python developer, Java developer, you want to get into some of those Copilot agents that Pamela was kind of just talking about, embedded agents. You can go and take a look there and explore and see what you want to learn more about. And finally, make sure that you submit your project once it's ready, before April 30th, 11:59 p.m. PST to win prizes. Thanks for joining.
Bye, everyone.